Welcome to this exploration of game theory, a fundamental analytical framework in economics. Game theory provides a powerful lens through which we can understand strategic interactions between rational decision makers. It offers insights into situations where the outcome for one participant depends not only on their own actions but also on the actions of others. This field studies how individuals or firms make choices when their interests are interdependent. It helps us predict behavior and understand the complex dynamics of competition and cooperation. Ultimately, game theory illuminates the strategic thinking behind many economic decisions. At the core of game theory lies a pivotal concept known as Nash equilibrium. This is a fundamental idea that underpins much of our understanding of strategic stability. It represents a state where no player can improve their outcome by unilaterally changing their strategy. A Nash equilibrium is achieved when each player's chosen strategy is the best response to the strategies chosen by all other players. This definition assumes that all other players' strategies remain unchanged. It signifies a point of balance where no individual has an incentive to deviate from their current course of action. The concept of Nash equilibrium holds immense importance in economic analysis due to its predictive and explanatory power. It is crucial for anticipating how economic agents will behave in various strategic settings. Understanding Nash equilibrium helps us forecast market outcomes and policy responses. Furthermore, it is essential for explaining observed economic phenomena. From pricing strategies to international trade agreements, Nash equilibrium provides a theoretical basis for understanding why certain outcomes prevail. It offers a logical explanation for seemingly complex interactions. Nash equilibrium finds extensive applications in economic modeling across diverse fields. It helps economists model situations like price wars between competing firms. By analyzing the payoffs, we can predict whether firms will engage in aggressive pricing or maintain higher margins. It is also invaluable for modeling advertising campaigns, where the effectiveness of one firm's marketing often depends on its rivals' efforts. Nash equilibrium helps determine optimal advertising budgets and strategies. Moreover, it is applied to negotiations, from labor disputes to international treaties. In all these scenarios, the actions of one player directly impact the payoffs of others. Nash equilibrium provides a structured way to analyze these interdependencies. It allows us to identify stable outcomes where no participant regrets their choice given the choices of others. Finding a Nash equilibrium involves a systematic, step-by-step process. The first crucial step is to define the game clearly and comprehensively. This involves identifying all the players involved in the strategic interaction. Next, we must list all their possible strategies, which are the complete plans of action available to each player. These strategies define the choices each player can make under different circumstances. Finally, we determine the payoffs for each possible combination of strategies. This information is often represented in a payoff matrix, especially for games with a small number of players and strategies. The payoff matrix displays the payoffs for each player for every possible outcome. Each cell in the matrix corresponds to a unique combination of strategies and shows the resulting utility or profit for each participant. The second step in this process is to identify the best responses for each player. To do this, we examine the payoff matrix from each player's perspective. For each possible strategy chosen by the other players, we determine the strategy that yields the highest payoff for the player in question. A best response is the strategy that maximizes a player's payoff, assuming the other player's strategies are fixed. We systematically go through each column or row of the payoff matrix, identifying the optimal choice for one player given the other's choice. This process is repeated for every player in the game. The third and final step is to identify the Nash equilibrium itself. A Nash equilibrium is a set of strategies, one for each player, where each player's chosen strategy is a best response to the strategies chosen by all other players. It is the point where all best responses intersect. This represents a stable state in the game. At a Nash equilibrium, no player has an incentive to unilaterally deviate from their chosen strategy. If any player were to change their strategy while others maintained theirs, their payoff would either decrease or stay the same. To illustrate the concept of Nash equilibrium, let us consider the classic example of the prisoner's dilemma. This scenario involves two suspects, let's call them Alice and Bob, who have been arrested for a crime. They are interrogated separately, meaning they cannot communicate with each other. Each prisoner faces two choices. They can either cooperate with each other by remaining silent, or they can defect by confessing to the crime and implicating their partner. The payoffs for each choice depend on what the other prisoner decides to do. This interdependence is key to the dilemma. If both Alice and Bob remain silent, they each receive a light sentence, perhaps 1 year. If one confesses and the other remains silent, the confessor goes free, and the silent one receives a heavy sentence, say 10 years. If both confess, they both receive a moderate sentence, perhaps 5 years. When we analyze this game, we find that the Nash equilibrium is for both prisoners to confess. This is because confessing is a dominant strategy for each player. Regardless of what the other prisoner does, confessing yields a better outcome for the individual. If Alice believes Bob will remain silent, she is better off confessing, going free instead of 1 year. If Alice believes Bob will confess, she is still better off confessing, 5 years instead of 10 years. The same logic applies to Bob. Therefore, both confessing is the stable outcome. This outcome illustrates a crucial implication. Individual rationality can lead to a collectively suboptimal outcome, while both remaining silent would result in a better collective outcome, 2 years total. The individual incentive to confess drives them to a worse collective state, 10 years total. The prisoner's dilemma highlights the tension between individual self-interest and collective well-being. Despite its profound utility, Nash equilibrium, like any model, comes with certain limitations. One significant assumption is that players are perfectly rational. This means they are assumed to always choose the strategy that maximizes their own payoff, and they are capable of complex strategic reasoning. However, in reality, human behavior can be influenced by emotions, biases, or cognitive limitations, leading to deviations from purely rational choices. Another limitation is the assumption that players are perfectly informed. This implies that all players know the rules of the game, the available strategies, and the payoffs for all participants. In many real-world economic situations, information is often incomplete or asymmetric. Players may not know their opponent's exact payoffs or even their full set of strategies. Furthermore, some games may have multiple Nash equilibria. When multiple equilibria exist, predicting which specific outcome will occur can be difficult. The theory itself does not always provide a clear mechanism for selecting among these stable states. This ambiguity can reduce the predictive power of the model in certain contexts. Despite these limitations, Nash equilibrium remains a cornerstone of game theory and a vital tool for economists. It provides a robust framework for analyzing complex strategic situations. Its power lies in its ability to simplify intricate interactions into a manageable analytical structure. It helps us understand how individuals and firms make decisions when their fates are intertwined. By identifying stable points in strategic interactions, Nash equilibrium offers profound insights into market behavior, policy design, and social dilemmas. It is crucial for understanding the intricate web of interdependent choices that characterize modern economic life.